So over here, we've got a question that has a diagram drawn out for us using rectangles. So we probably will be thinking about how to use the area of the rectangles. Very typically, if they're giving us questions like this, we might be looking at the area of the circumscribed or the inscribed rectangles, and then doing a bit of comparison to the exact area. So let's take a look at what the question actually asks us to do. It says the curve y equals x cubed plus x is drawn and divided into n intervals between 0 and 1. The inner rectangles are completed as shown. So you can quite clearly see the rectangle areas are below the exact area in this example here. They say if AN is the area of these rectangles, show this. And then, given that the area bounded by the rectangles between the x and 1, and the x-axis limit is AN, find the value of AN using the result in part 1. Okay. So, we want to find the area of the rectangles. AN is the area of the rectangles. Which clearly is, I guess, area 1, area 2, area 3, all the way up to, well, I guess the last rectangle. So we might want to think about, well, how many rectangles are there? There's the first rectangle here, which goes from 1 to 2. There's the second rectangle from 2 to 3. There's 3 rectangles. The third rectangle goes from 3 to 4. So you can see that the first rectangle starts at 1 over n. The second rectangle starts at 2 over n on the left. The third one starts at 3 over n on the left. So I guess this rectangle must be starting on the left. So this is the n minus 1th rectangle. So there are n minus 1 rectangles. Okay, not n, but n minus 1. Now, how do you work out the area of a rectangle? Well, an area of a rectangle is just the length times the width. Well, we'll need to work out the width, and we'll need to work out we'll call it height here. But once we work out the length and the width and the height of each one, we just multiply them together, and then that's the one for each one. So it should hopefully be clear that the width is going to be 2 over n minus 1 over n. So as an example, which is 1 over n. And hopefully it should be quite clear that all of these widths are 1 over n, like 1 to 2, 2 to 3, 3 to 4, and so on. So all of these are 1 over n. We've got the width. Now the height might be a bit more problematic. We'll notice that the height of this one is determined by this length here. And this length is just the y value. So this is the y value at x equals 1 over n, which is just y equals 1 over n all cubed plus 1 over n. In other words, it's f of 1 over n, where f is this function here. This one is going to be f of 2 over n. This height is going to be f of 3 over n, and so on. And so the last rectangle is going to be f of n minus 1 over n. So it would appear that the length is going to be f of, well, k over n, where k goes from 1 to all the way up to n minus 1. So in other words, for the first rectangle, it's f of 1 over n being the height times 1 over n. For the second rectangle, it's f of 2 over n being, again, the height times 1 over n. So in other words, the kth rectangle is f of k over n times 1 over n. And we have to add them all up. So what we're really essentially saying is, let's get a bit more space over here. We're saying that we want to have, well, f of 1 over n times 1 over n plus f of 2 over n times 1 over n plus dot, 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 plus f of n minus 1 over n times 1 n. That would be all your rectangle areas added together. You can take out 1 over n, and that will be f of 1 over n plus dot 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 plus f of n minus 1 over n. Well, if we can, I mean, it's a lot of writing without sigma, but we'll stay away from sigma at the moment. What does that mean, though? Remember, over here, f of x is x cubed plus x. So we're really saying this is 1 over n or cubed plus 1 over n. And then we're going to add 2 over n or cubed plus 2 over n plus 3 over n or cubed plus 3 over n plus dot 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 dot. It will keep going until your last rectangle, which is n minus 1 over n or cubed plus n minus 1 over n. So that means that if we group this up like this, and like this, then the left-hand side is actually going to be the sum of, well, k over n cubed, k over n or cubed, from k is from 1 to n minus 1. The right-hand side will be the sum from k equals 1 to n minus 1 of k over n. So in other words, this is where some more space might be helpful. At this point, we've got an equals 1 over n times the sum from k equals 1 to n minus 1 of k over n all cubed plus the sum from k equals 1 to n minus 1 of k over n. And you can write that as k cubed over n cubed. Now this is k over n. We'll note that n is not dependent on k. So it doesn't matter what k is. K could be 1, 2, 3, 4, all the way to n minus 1. But basically, n is n. So we can take out that n cubed. And we can take out the n. And we can just multiply the 1 over n inside. And that is what they asked us to show. They asked us to show that an, the sum of the rectangles, is 1 over n to the power of 4 with sigma from k equals 1 to n minus 1 of, well, I mean, I use k, they use r. It's really the same thing. It's just a counter. You can change the letter to r. It doesn't matter. So we've now shown that the area of the rectangles is equal to, well, that expression there. The question now asks, given that the area bounded by the curve between x equals 0 and x equals 1, and the x-axis is the limit as n goes to infinity of an, and we could work that out if we wanted, using integration. Find a value for an using the result in part 1. Okay, we'll just note that part 1 is just telling us the sum from k equals 0 to n, well, k equals 1 to n, I should say, although it won't make a difference, of k cubed is just going to be n squared over 4, n plus 1 all squared. It's basically sum of cubes. So we'll use that to apply to here. Specifically, you can probably see it's going to apply to that. And then we'll basically simplify it and see where it takes us. So At this point in time, we have an equals 1 over n to the power of 4, the sum from, they're using r, so we use r equals 1 to n minus 1 of r cubed, plus 1 over n squared, the sum of r equals 1 to n minus 1 and r. Now, we do have the result from part 1, which we'll write out again here. We know that the sum from r equals 1 to n of r cubed equals n squared over 4, n plus 1 all squared. So, applied here, noting that it's, well, from 1 to n minus 1, that's going to be 1 over n to the power of 4, n minus 1 all squared over 4, n squared. Right, because you're letting it be n minus 1, plus 1 over n squared, and you're summing from 1 to n minus 1, so that means it's going to be n minus 1 over 2 times n. So this is just a sum of a GP, right? Sum of an AP, because you're really just adding 1 plus 2 plus all the way up to n minus 1, which you understand is the first term plus the last term multiplied by the number of terms all over 2, which gives us what we've written out there. Your n squared cancels. Your n cancels with that. That means you're going to have n minus 1 all squared over 4n squared plus n minus 1 over 2n. And so we've got n minus 1 all squared plus 2n n minus 1 all over 4n squared. And we might just quickly expand. It's got 2n squared so plus 2n minus 2n gives you 0. So we've got 3n squared plus 1 over 4n squared. So that's our solution to an. We could, of course, also just check this conceptually. The question was telling us that as n goes to infinity, it goes to the exact value. So if we expect an to equal 3n squared plus 1 over 4n squared, then it's quite clear as n approaches infinity, an approaches 3/4. And we can quickly check if that makes sense. We're expecting that to be, I guess, the exact value under the curve y equals x cubed plus x from x equals 0 to x equals 1. So in other words, we're expecting the integral from 0 to 1 of x cubed plus x dx to hopefully equal 3/4. So let's take a look. It'll be 1/4 x power 4 plus a half x squared, 1, 0, which is a quarter plus a half, which is indeed 3/4. So that check works out. And so we expect that to be the answer. The question did say to find a value for an, which doesn't seem to make sense without knowing what an. It should be really finding an expression for an, or they should have told you to find a value for an as n goes to infinity. So the way the question is worded doesn't exactly make a whole lot of sense. Should be finding an expression for an, or finding a value assuming n goes to infinity, in which case you could just directly integrate it. But regardless, I think that is probably the question they intended, and it is consistent with what we expect as n goes to infinity. And that's how we do the question.